Morning, guys. How are y'all doing? Hey, Mr. Terrell. Hey. All right. Jake, you asked me about my bracket. It's busted right now.
Bad?
Yeah, it's bad. Did I tell you guys last year, though, I came in 6th on the ESPN bracket?
Did you really?
Yeah.
Nice.
Did you win any money?
No. I think like the top 1% get put in a drawing. And that's like, if there's 10 million, that's still like 100,000 people or something like that. So I didn't win, but we'll see what happens this year. Okay. All right. So do you guys all have a note packet? So everybody got one of these? Yep. Okay. The first thing is centripetal acceleration. I had you guys do some notes while I was gone Monday on this. Okay. Centripetal acceleration is just if something's moving in a circular path. Okay. It has a tendency to want to accelerate towards the center, all right, towards what it's rotating about. And if you take these two words, okay, if you take the GRE, once you graduate from college, all right, it's really hard, but if you know how to do prefixes and suffixes, it really helps you out because you'll get words that are like this long, and you'll have no clue what they mean. And so you try to break them into little parts. So if you can pick up some of this stuff while you're in high school, that's a good thing. Okay. So centripetal means centra means center. Pedal means seeking. And we'll talk about centrifugal, which means center, and fugal means fleeing. Okay. It's just the opposite. All right. The equation is v squared over r. Now, did we do a lab with this, twirling a thing around? All right. At the end of class, I'm gonna have you guys go back and look at your data. And see if you can come up with this is proportional to v squared. Okay. Your data should show that that works out, but we'll see. Okay. Something else, I had a lot of people ask me questions about tangential velocity. Okay. If I have a ball on a rope, okay, if I swing it around like this, okay, if I were to cut the rope right here, which way would this ball want to go? Does it want to keep going in a circle? No. It wants to go straight out like this, correct? Is that tangent to this curve? Yes, that's why we call it tangential velocity, okay? And if I look at this, if that's true, would this continue to go in a circle? No, but check this out. What happens is you have an acceleration that pulls it back this way, back towards the center. And what is that acceleration called? Centripetal acceleration. And if it pulls it back, does this stay in the circle? All right, if I were to now cut the string here, it would go like that. But centripetal acceleration pulls it back towards the center, which keeps it moving in a circle. Okay? Now, if you guys know satellites that go around the Earth, right? Technically, what they're doing the whole time is they want to go straight, but Earth's gravity is pulling it back. So technically, the satellites are in free fall the whole entire time. So you see people in the spacecraft, right? And it looks like they're floating around. The reason they're floating around is because this is always accelerating it back towards the center of Earth. So technically, they are in free fall the entire time. Okay? And the equation for it is v squared over r. All right, centripetal force. This is where a lot of people get confused. Okay? This is a type of force. It's not really a force. And you're probably like, that makes no sense at all. What in the world do you mean? Okay? All right. It is a force, but notice what it has to have in order to be a force. All right. Here, if I have a ball on a string, correct? If I cut the string, will this accelerate around the circle anymore? No. No. So you need a tension in that case. Okay? If you're in your car and you're making a turn, what type of force do you think you need to help you to accelerate back towards the center? Friction. Excellent. Okay. Have you guys ever rode the graviton machine? The thing that it's like this big like cylinder, and you like stand up against the wall like this, or if you're like me, I try to do like some crazy pose, and then like once it starts, you're just like, you just like stick to the wall. And then you're like, all the blood rushes to your head and you pass out. You wake up on the floor, right? I've done that before. I see a bunch of people like freaking out, like what's going on? Alright, I like to do it upside down and stuff, okay? But what is causing an acceleration in that case? Am I up against an object? Am I touching an object? So what's pushing me this way? What's accelerating me this way? The wall. And what type of force is that? A normal force. If I'm touching a surface, it's a normal force. Good. Alright, so do you guys understand, like, this isn't a force in itself. It has to have like tension or gravity or some other force to help it act back towards the center.
So, like, category that other forces would fall under?
I would say so. I mean, it's actually just a force by itself. But you have to have these other forces applying to it in order for it to actually work. So it can't be by itself. You can't just have a centripetal force and not have tension, friction, or gravity. So I guess you could say these are like underneath this. You have to have one of these underneath centripetal force. Okay. All right. Always points towards the center. We talked about that. All right. First problem. Okay. If you like free body diagrams, we're going to do some more. Okay. So a child is sitting on a 1.5 meter, or sitting 1.5 meters from the center of a highly polished wooden rotating disc. The coefficient of static friction between the disc and the child is 0.3. Okay. So 1.5 meters. All right, Michael, what's 1.5 meters? Well, it is 150. What is this telling me? What variable is this telling me?
Delta Y.
All right, and if I'm going in a circle, right, it says it's from the center.
Oh,
So I'm going here to here.
Radius.
It's the radius, good. So R is 1.5, good. It is a delta Y, okay. What is, let's see, who do I want to call him now? All right, Kennedy, what's 0.3? What's that tell me?
Static friction.
Okay, and do you remember the symbol for that? Goo, good. US, excellent. I just made my daughter's, I said goo. Instead of good, I'm sorry. I play with her way too much. I feel stupid now after saying that. You did a good job. Alright. What's the maximum speed that the child can have before slipping off the disc? Alright, so you need, does everybody agree that I need to look at VT, tangential velocity? Okay. So here's what we're going to do. We need to look at a free body diagram of this child. Okay. I'm going to look at a side view.
Can you draw a picture?
Like draw a picture of it? Okay. So over here, I'll do a top view. So this is 1.5. The child's right here, correct? This is a top view, and this will be, for our FBD, we'll look at a side view. Okay, so this is looking down on top of this thing spinning. And that'll be the side view. So if I looked at the side, what's the child doing? Okay? Okay. Amal, what's a force that's acting on this child? Well, alright, the centripetal force, but remember it can't just be a force by itself. What's causing that centripetal acceleration? What's causing the child to want to go back this way? Static friction, good. And which way is it going to point? If the child's here, which way does friction point? Which way does the force want to pull this child?
The opposite.
Alright, the child feels like it wants to move this way, correct? Have you ever been in a car and you take a turn and you feel like you want to go this way? Right? So, which way is friction acting? This way. So the force of friction's right there. Okay? Mahiko, what's another force acting on this child? So they're setting on this wooden rotating disc. So if I set on the table, right? Gravity, okay. And Drew, what's another force? So gravity pulls me down. Why don't I hit the ground? Normal, good. So I need to draw those in. Got the force of gravity.